Okay, last week before the weather day, we had this great bell ringer, and I wasn't going to let it go to waste. So we're doing Friday's bell ringer today. It says in the figure, line L is parallel to line M, line AC is parallel to line BD, and name all the pairs of angles for each type of angle, each type indicated. So alternate interior, 6 and 4 would be alternate interior. So would 2 and 8. But heck, 1 and 5 look like alternate. Are they interior? Yeah. And 3 and 7 look like alternate interior. So I've got a list of 4 different pairs. I'd said 1 and 5, 6 and 4, 2 and 8, 3 and 7. But that's just dealing with line L being parallel to line M and this line being the transversal. Because if you read over the directions, it says that L is parallel to M, which means that line's a transversal, hence why me and you said these two are alternate interior and these two are alternate interior. That would also make this a transversal, so these two are alternate interior and these two are alternate interior. But the problem tells you not only are line L and M parallel, but lines AC and BD are also parallel. So our list is not actually long enough. Our list, even though it has 4 things on it, it's not long enough because there's another set of parallel lines. So if AC are the parallel lines, that means L is cutting through but alternate interior, I don't see anyone alternate with my list. I got 6, 1, 2, 7. None of those are alternate, meaning on opposite sides of the transversal. And with my other transversal, line M, and the 5 and the 4 and the 3 and the 8, none of those are alternate either. They're both on the same side of that transversal. So I'm actually for real done with that list. That's all my alternate interior angles. But the reason I mention that is it's going to change our list with consecutive interior. Okay, so all our consecutive interior would mean they're on the same side of the transversal and they're on the inside. So 1 and 4 are consecutive interior. They're on the same side of a transversal. They're both on the right side of AC. And they're both on the inside. So angle 1 and angle 4, that's one type. Angle 6 and angle 5, they're both inside. They're both on that left side of that line, so they're both consecutive interior. And then 7 and 8 are both consecutive interior. Same side of the transversal, both in between the two lines, L and M. And then 2 and 3 are also consecutive interior. And I think that's all, unless anyone else has any more they want to add. I think that's all I can come up with, although I haven't done math in a couple days like you. So I'm going to move on from that one. If you missed and didn't at least have a list with a couple on it for that one, then that makes me sad. Okay, anyone have an answer for number 2? Someone foiled it out and got an answer. Yeah, G, she says? Is it J? Okay, so first it would be 4z times z, which is 4z squared. And then outer, that'd be negative 8z. Inner would be 3z. And then last would be negative 6. So I get 4z squared, and then if I combine those two middle terms, because they're like, you get negative 5z, and then minus 6. So I do get j. Now, if I was guessing, I wouldn't have guessed f or g, because most of the answers had 3 terms. And then it looked like 6 kept popping up, and so did 5. So I would have not guessed h. I was going to either guess j or k to begin with. And I probably should have guessed j because all the others are negative for that term. Why would I pick the one that's like a positive 5z? Everyone else had negative for the next second term. So I think I could have guessed my way into that one. Okay, and then the last question says if 40% of a number is 8, of a given number is 8, then what is 15% of the given number? So there's some number times 40%, and you get 8. And then they want to know what is 15% of that same number. So I guess I should solve for x right here.
Good morning, teachers.
Okay.
Someone tell me what 8 divided by 0.40 is before he comes back on, so we can at least get the bell ring or something. 20? Thank you. Do
Good morning,
0.15 times 20.
All tardy students, first period tardy students directly to class. Please allow them into class. We will write passes for students for second period. Thank you very much.
Okay.
Have a good day.
Okay. Thanks. You could have just emailed me that 3 hours ago, but it doesn't matter now. Moving on. What's 0.15 times 20? So 3.0. So the answer is C. Woohoo. So I figured out what x was. X was 20. And then I plugged x in.
Teachers, we are sending all
got
the
3.0.
students to class. If you have marked them absent, just send me an email, but we're just sending them on to class at this time. Please let them into your room.
Would have done that 3 years ago. No. Okay, are there any questions about that bell ringer question? It's a pretty easy one, but with 5 interruptions, it suddenly becomes really, really difficult. Okay, get out your 6-3 notes. 6-3? Am I crazy? Isn't that 6-3? Yeah, it is 6-3. So we filled in the 6-2 notes last week. We're going to do the 6-3 notes now, but we're going to do them quickly. 6-3 is actually super easy. And there's a reason for that. Okay, has anyone lost their notes and needs a new copy? Okay, I'm going to go over these really quickly, and honestly, there's not much new information to learn. So 6-2, we learned 3 things. What were the 3 things we learned in 6-2 about parallelogram?
Opposite sides are congruent.
Opposite sides are congruent. Consecutive angles are supplementary. Diagonals bisect. Those 3 things are still listed on the board, and if you don't remember those 3 things, you didn't really understand 6-2. For 6-3, all you still need is those 3 things. That sounds crazy, that 2 sections just need these 3 facts, but it's true. So 6-2 says, here you have a parallelogram, so all these properties happen. 6-3 says, is this a parallelogram? And you show it really is because you have at least one of these properties. So they're going to say, prove this is a parallelogram. So to prove that something's a parallelogram, you're just going to show it has one of these properties. So we're going to prove, so it says it's a test for proving parallelograms. We're going to prove that opposite sides are congruent. I don't know why they listed it twice. I guess because there are 2 opposite sides. We're going to prove that opposite angles are congruent as well. Consecutive angles are supplementary. Diagonals bisect each other. Really the same 3 facts we've been going over and over. Morning, dear. Okay, only one pair of congruent parallel sides is sufficient. You don't have to show, you can overkill it and show everybody is equal. You can show that FG and JH are both 14, and then you might can measure it and show that FJ and GH are also 23 or whatever, but you don't have to. As long as 2 of the sides are congruent, you can assume both pairs of sides are congruent. So this one says determine if the quadrilateral shown is a parallelogram, justify your answer. Well, we could say, I want to say yes because I know I have FG is congruent to JH. Miss Compton, don't you know your alphabet this morning? So I know I have opposite sides congruent. I also know that angle G and angle H are supplementary because 100 plus 80 is 180. So because I have the opposite sides congruent and I have consecutive angles supplementary, I know that this indeed is parallelogram. So F, G, J, H is a parallelogram. Should have named it HJ. Just one of those days today. Shouldn't be allowed to write in pen. F, G, H, J. F, G, H, J. So again, 6-3 is when they say, is this a parallelogram? And you just have to show you have a couple of these facts to prove that the shape you're given really is parallelogram. So on the next one it says FK is 3x minus 1. KG is 4y minus 3. JK is 6y minus 2. KH is 2x minus 3. Labeling, ooh, Lord, help us all. Labeling each of these little pieces of the diagonal is the hardest part in the problem. Because it says, find x and y so that the quadrilateral is a parallelogram. Okay, and this is what I asked you all last week. What they gave me. Did they give me something with the sides? Did they give me something with the angles? Or did they give me something with the diagonals? It is definitely the diagonals. And what are the diagonals in a parallelogram supposed to do? Which means they're supposed to be equal to each other. So I'm going to do 3x minus 1 equals 2x minus 3. I'm also going to do 6y minus 2 equals 4y minus 3. The two tiny pieces on the diagonal should be equal to each other. And if you solve I got x equals negative 2, which can't possibly be right, so Ms. Compton needs to check her math this morning. Oh no, it is right for once in my life. I don't like that at all. And then y equals negative 1/2. Okay, I can promise you this much. If there was ever an example that I could tell you will not be on the test, is this one. Because I don't like it because you got negative values. I don't think x and y should end up being negative. That kind of confuses people. Here in geometry, we like to live in positive land, especially when we're talking about how long something is. If you plug it in, you'll be even more concerned because you'll get 3 times negative 2 minus 1. Negative 6 minus 1 is negative 7. 2 times negative 2 minus 3. Negative 4 minus 3 is also negative 7. Yes, they match, but it doesn't make sense for something that you actually measure to be a negative length. So I think this entire problem is silly. But we've done it. That's all we had to do. So 6-3 and 6-2 are really a little too similar for comfort. Okay, 3A, are we dealing with opposite sides, consecutive angles being supplementary, or diagonals bisect? which of those three properties? Are we doing sides, angles, or diagonals? We're doing angles. Okay, we know the opposite ones are supposed to be congruent. So first things first, 56 equals 7x, so x equals 8. Now, if I know this is 56, then I can figure out what I need for this angle because they're supposed to add up to 180 because consecutive angles are supplementary. So what is 180 minus 56? It is 124. Good. So I know this angle should be 124 degrees because these two angles are supposed to be supplementary. They're supposed to add up to 180. So I'm going to do 4y plus 4 equals 124. So I'll get 4y equals 120. So y8 equals 30. Now again, all I'm using is facts that I know about parallelograms. So if this is a parallelogram, then not only are these opposites congruent, but the two on the same side are supplementary.
So if we also do if 4y plus 4 equals 5y minus 26.
You could do 4y plus 4 equals 5y minus 26. But did you end up getting a value for y? Do you still get the same thing? Do you still get 30? Well, I want to know, yeah. 5y minus 26. 4y equals 5y plus 30. I get y equals negative 30? No, I don't. You're right. I get y equals 30 either way. Good. Good. You still would get the y equals 30. So what the girls wanted to do with this front table, which was smart, why don't we just, if we know those two are supposed to match, why not set them equal style for y? They still got y as 30. Didn't matter which way you did. Perfect. Thank you, girls. Okay, and the next example obviously is dealing with opposite sides being congruent. So 4y minus 9 equals 2y plus 5. So 2y minus 9 equals 5. 2y equals 14. Y equals 7. And I can check myself. 2 times 7 is 14 plus 5. Hey, that's 19. 4 times 7 is 28 minus 9. Hey, that's also 19. So I know I'm right. And then I can also do the other pair of opposite sides. 2x, 4 equals 2x minus 2, 6 equals 2x, 3 equals x. I got 3. But then I'm not sure, and I want an A in math class, so I plug it in. 9 plus 4 is 13. 15 minus 2, hey, that's also 13. So I know I'm right. Again, I'm still just using one of these three properties. I'm using opposite sides being congruent and showing that what they gave me really is a parallelogram. I'm making it a parallelogram. Okay, are there any questions about any of these? There is one more, and it's got to do with graphing, so it's not really in the same realm as these. So it says, use the slope formula to determine if the quadrilateral is a parallelogram. It's going to be a parallelogram if, hello dear, this line and this line have the same slope. So we need to calculate that slope. We need to know the slope. I don't even want it. I don't even want it. Huh?
What I said.
I don't care. So I need to calculate the slope. Now, if you want to actually figure out the coordinates and plug in the slope formula, of course you can. I'm kind of lazy this morning, so I'm just going to count it and see if they have the same slope. So to go from N up to K, I would go up 1, 2, 3, 4, 5, 6, and to the right one, so 6 over 1, so the slope is 6. I need to make sure that this one has the same slope, so up 1, 2, 3, 4, 5, 6 over 1. Yep, it's got the same slope. So I know those two lines are indeed parallel. And then I also need to do the same logic with KL and NM. So to go from K to L, I would go up 1 over 1, 2, 3, 4, 5, 6, 1 over 6. And to go from N to M, I would go up 1 and over 1, 2, 3, 4, 5, 6, so 1 over 6. So I'll end up showing, and my colors aren't very good, so I end up showing the two red lines, KN and LM, have the same slope. And I show KL and NM have the same slopes. So since I kept getting 6 and 6 and then 1, 6 and 1, 6, I've shown that I have a parallelogram. Because all the sides are the same slope, so they are parallel. Well, opposite sides are parallel. Okay, the reason we did this one is because if they're going to put one on the ACT, they're probably going to do something like this. Again, they want to test not only does Harrison understand parallelograms, but can he graph. This way they can knock out 2 skills at the same time. That's why they like this kind of a question more so than what we were doing earlier in the notes. Are there any questions about any of these? I think now you're able to handle all the worksheets we discussed. Here, let me stop this recording.